Alright, so let's understand this problem called human traffic of stadium. So over here we are given a table called stadium which records the number of people visiting the stadium on different days. And each row contains 3 columns. ID, which is a unique identifier for the visit, visit underscore date, that is the date of the visit, and the people, which is the number of visitors on that day. Now the task is to find all the records where there are 3 or more consecutive IDs, and on each of those days the number of people is at least 100. So essentially we are looking for high traffic streaks. So let's look at the input table. We have multiple days of stadium visits with different visitor counts, right? Now notice that some days have less than 100 visitors while others have 100 or more visitors. Now let's look at the expected output. Now in the result, if you see, we return the rows with IDs 5, 6, 7 and 8. And these rows form a sequence of at least 3 consecutive IDs and each of them has 100 or more visitors. So this is exactly the kind of streak we are trying to detect. Now maybe let's see how we can solve this step by step. So first we filter the rows where the number of people is greater than or equal to 100 because the problem only cares about high traffic days, right? So we remove all the rows where people is less than 100. Now after filtering, the table now contains only the rows where the visitor count meets the requirement. However, we still need to detect the consecutive sequence of IDs. And to do that, we will use a very powerful SQL trick now. So next, we assign a row number to each row based on the order of the ID column, right? And we do this using the window function row number and we just order by ID. So this simply numbers the rows sequentially. Now every row gets a row number starting from 1. And at this point we have 2 numbers for every row, right? Which is the original ID and the generated row number column. And now we will use these 2 values to detect consecutive sequences. So here comes the key trick. Now we compute another new column called group ID and this will be calculated as the original ID, which is the ID column, minus row number, right? So let's see what happens. So for example, if the ID is 5 and the row number is 3, the group ID becomes 2. Now if the ID is 6 and row number is 4, the group ID again becomes 2. And if the ID is 7 and row number 5, the group ID is still 2. So notice something very interesting over here. Whenever the IDs are consecutive, the value of ID minus row number stays constant. And this means all the consecutive rows automatically fall in the same group. So this simple formula will allow us to group consecutive sequences together. And this is one of the most useful tricks in SQL interview problems. Okay, so now we count how many rows exist inside each group, right? So now again we will use a window function. We will just count the number of rows over partition by group ID that we have just assigned, right? And this will count how many rows share the same group identifier. So for the group that contains ID 5, 6, 7 and 8, the count becomes 4, right? And this tells us that this sequence contains 4 consecutive high traffic days. Now finally, we filter the rows where the group count is greater than or equal to 3 because the problem requires at least 3 consecutive records. So any group with fewer than 3 rows is removed and the remaining rows represent the valid traffic streaks, right? So now maybe let's see how to implement this logic in SQL. So we start by creating our first common table expression called filtered. And here we simply select all the rows from the stadium table where the number of people is greater than or equal to 100. And this step removes all the low traffic days. Next, we create another CTE called grouped. And in this step, we compute the group identifier. So we calculate ID minus row number over order by ID, right? And this is what we saw earlier. And now this will create the grouping key that will allow us to detect consecutive IDs, right? That means the rows that belong to the same consecutive sequence will share the same group ID. Now we create the third CTE called num_rec, and here we will count the number of rows that belong to each group. So we use the window function again, that is count star over partition by group ID, and this will tell us the length of each consecutive sequence. Finally, we select the columns ID, visit_date and people, but we only keep rows where the group count is greater than or equal to 3. And this ensures that we return only those sequences that contain at least 3 consecutive high traffic days, right? And we also order the results by visit_date. Now when we run this query, we get the final result. The rows with IDs 5, 6, 7 and 8 are returned, and these rows form a sequence of 4 consecutive IDs, and each day had at least 100 visitors. So this sequence satisfies the problem requirement, and this is going to be our final output. So that's how we can efficiently solve the human traffic of stadium problem using the SQL window functions, right? So that's it for this particular problem, and now I will see you in the next one. Happy coding!